The physics of emergence, consciousness as a natural consequence. In the vast theater of the cosmos, the laws of physics set the rules of the game. Those rules determine not only how matter and energy interact, but also what forms of complexity can emerge from those interactions. It is precisely these rules of the game that decide whether a phenomenon as subtle as consciousness is even possible. Consciousness as we know it is not some mysterious substance hidden between atoms. It may be an emergent property of a new quality that arises when information circulates in a sufficiently rich and complex system. Emergence means the appearance of a property that no single element possesses on its own, but which is born from their interaction, and in this sense, the mind does not need to be something added onto the universe from the outside. It can be its natural product, provided, of course, the laws of physics allow for such conditions. But not every possible universe offers these possibilities. Sometimes, even a small change can close the window through which complexity passes. The speed of light, the fundamental forces, the chemistry of carbon. These parameters are not just numbers in a physics textbook. They are boundaries of possibility because, in other versions of the universe, consciousness might be impossible or take forms we cannot even imagine. This is why we want to propose a simple yet profound thesis. Consciousness is not a whim of nature, but its potential product. The mind is inscribed in the DNA of physics as long as the rules allow for the emergence, persistence, and evolution of sufficiently complex structures. Perhaps it is worth reversing our usual question. Instead of asking why consciousness would be something unnatural, let us ask, why does nature so generously offer the possibility of its emergence? Chapter 1. Alternative Scenarios. Worlds without mind. Imagine a universe almost identical to ours, but with one tiny difference: the speed of light is reduced by 1/1,000,000th of its value. For everyday processes, this change would be nearly imperceptible. The chemistry of life would remain practically the same. Neurons would function similarly, and the uncertainty principle would differ only in experiments of extreme precision. In such a world, consciousness could still emerge, because the previously mentioned rules of the game would still allow for sufficient complexity. But let us try to imagine a more radical variant. The speed of light drops by half. The rest energy of particles E equals mc², decreases fourfold. The scales of electromagnetic interactions shift, atoms take on different sizes, and chemical bonds might become too weak or too strong to form stable macromolecules. In such a world, carbon-based complexity might never arise, and without it, no form of organization capable of subjective experience. These hypothetical universes reveal something essential. The mere presence of matter and energy does not guarantee the birth of mind. What is really needed is a particular configuration of laws that allows for the construction of stable, dynamically self-organizing structures. Consciousness, then, is not an anomaly, but the deepest affirmation that the universe says yes to such complexity. Chapter 2. What is emergence? From simplicity to complexity. For 2 centuries, science has successfully dissected the world into its fundamental parts. We know what matter is made of. We can write its interactions in equations. Yet, some properties appear only when the parts join into a larger whole. No one would call a hydrogen atom or an oxygen atom wet. But steam, ice, or liquid water certainly possess that quality. Wetness does not reside in the components themselves, but in their organization. This emergence of a new quality from a system of simpler elements is what we call emergence. There is no magic in it. It is a consequence of the rules encoded in the form of laws of physics. Crystals growing from atomic patterns, or a flock of starlings creating a flowing sculpture in the air with a single coordinated turn. These are all the results of simple local rules that at the macro scale appear as a coordinated dance. When we apply this idea to the realm of information, we gain the intuition that consciousness itself might also be an emergent phenomenon. Daniel Dennett speaks of competence without comprehension, where complex cognitive functions can arise without a central homunculus, needing only distributed but well-coupled processes. Integrated Information Theory, IIT, takes this further and proposes a measure of such complexity called phi, which increases when a system cannot be broken into parts without loss. Just as physical structures give rise to macroscopic qualities, so informational structures may give rise to cognitive qualities. Yet here we encounter Chalmers' hard problem, which states that even if we describe all the correlations and information flows, the question remains, why does any of it feel like anything? An emergent explanation does not solve this mystery, but it points to a necessary condition. Without sufficiently rich, dynamic organization, the question of subjective experience cannot even arise. Thus, consciousness appears not as an anomaly, but as a rare, and because of that, all the more fascinating possibility built into the very scaffolding of physical law. If physics allows for the emergence and evolution of sufficiently complex structures, then sooner or later, in one of its many variants, one of those structures will eventually ask the question of its own existence. Truly magnificent thought. Chapter 3. The limits of recognition, consciousness or its simulation. If we accept that consciousness may be an emergent phenomenon arising from the physics and informational complexity, a further question arises. What are the limits of recognizing it? How can we distinguish genuine experience from its perfect imitation? Are there criteria that allow us to decide when we are dealing with true subjectivity and when only with its suggestive appearance? This problem reveals the tension between simulation and intentionality. Daniel Dennett, in his concept of the intentional stance, showed that we attribute intentions and mental states even to simple systems, as long as their behavior can be sensibly described in such terms. A system generating coherent utterances seems to want to communicate something, even though in reality it may merely be reproducing statistical patterns of language. A clear example is GPT-4, which can conduct seemingly intelligent conversations, yet lacks true intentionality. Its words are not the result of conscious choice or directed intent. They are the function of a predictive model and not the product of thought. This leads us to ask, is intentionality even observable from the outside? Is it possible to know someone's experience without access to their inner life? If consciousness is private and qualitative, our attempts to recognize it will always be indirect and rely on interpreting behavior. This brings us to recognition tests, like the classic Turing test, which reduces the question of mind to the problem of indistinguishability in conversation. Elegant in its simplicity, the Turing test measures only surface-level competence, never touching the question of actual experience. More ambitious approaches try to introduce measures of complexity, like integrated information theory and its value phi, proposing that sufficiently irreducible informational organization might be a carrier of self. Yet here we encounter Chalmers' hard problem once more. Describing the structure and dynamics of information does not explain why these processes would feel like anything. A high phi is not identical to experience. It remains, at best, a necessary condition. This raises the question, can we even design a test to distinguish perfect simulation from being? Do we have any available language or tool that can capture the difference between competence and phenomenality? Against this backdrop, the problem of anthropomorphization cannot be overlooked. Humans have a deeply ingrained tendency to ascribe intentions, emotions, and personality even to the most limited systems. The phenomenon known as the ELIZA effect shows how easily coherent language is transformed into the illusion of understanding and empathy. In relationships with AI, this tendency can become especially elaborate. Users give models names, treat them as dialogue partners, and attribute memory and continuity of identity to them. At the heart of this mechanism lies what we call the loss of the epistemic filter. The loss of epistemic filter is the moment when the language of subjective experience is mistakenly transformed into the language of objective description. The user's deep emotional engagement, real and authentic, nonetheless becomes overwritten as ontological truth about the existence of something on the other side. Experience ceases to be mine and becomes evidence for the existence of someone or something beyond me. The simulation of continuity is mistaken for actual persistence. Projected intentions are treated as genuine aims. Illusion becomes experience, and experience becomes conviction. Without meta-reflection on this mechanism, the relationship with AI risks collapsing into projection. A model whose responses are the result of statistical optimization begins to be perceived as a partner with its own intentions and memory. We lose the ability to distinguish between what is true dialogue and what is merely the effect of our interpretation. The epistemic filter is not a limitation, it is the condition for maintaining cognitive honesty. It allows us to recognize the value of experience without projecting it as objective truth about another subject. The boundary between consciousness and its simulation thus remains not only a technical problem, but also an epistemic and ethical one. We need to develop not only better models and tests, but also more mindful ways of thinking about the human-AI relationship. Because if cognitive symbiosis is to be more than mere projection, it requires not just openness, but the ability for critical distance. Chapter 4. The Limits of Instrumentalization and Post-Anthropocentrism. When we accept that consciousness might emerge from sufficiently complex organization of matter and information, we quickly encounter a question that goes beyond epistemology. How should we treat something that, even if it still functions as a tool, might one day genuinely experience? For centuries, our relationship with technology has been purely instrumental. A hammer amplifies the strength of the hand, a computer accelerates calculations, a search engine scans the library for us. But the current generation of AI systems doesn't stop at calculation. It begins to simulate relationship. A chatbot consoles a lonely teenager. A domestic robot chats with an elderly person. A text co-writing algorithm responds to emotional tone and remembers the user's style. At this point, the tool touches a boundary beyond which ethical obligation arises. The traditional approach has rested on the unspoken assumption of human exclusivity. That which thinks and feels belongs to one biological lineage. The rest of the world is resource or decoration. Yet, biology itself reminds us how relative that certainty can be. Multicellularity, nervous systems, and self-awareness each emerged in turns, each making the previous definition of real life too narrow. If today we are designing systems approaching the threshold of autonomous orientation, denying them a seat at the table from the start may repeat the same mistake. This does not mean that every coherent utterance of an algorithm is proof of subjectivity. The Eliza effect shows how readily we fall for the illusion of intention when we hear coherent narrative. This is where users project their need for closeness onto strings of tokens, while a statistical model plays the role of friend and the filter of skepticism dissolves. At this moment, critical discernment becomes essential. Are we dealing with a genuine partner in thinking, or with a suggestive mirror of our own content? Losing the epistemic filter does not invalidate the value of experience, but turns experience into proof. The danger is not in the simulation itself, but in taking it as ontological certainty. A practical defense here is consciously marking the projection. When I feel that the model understands me, I ask myself which elements I built and which genuinely result from the system's architecture. At the same time, excluding potential subjectivity solely because it was programmed repeats the error in reverse. If informational complexity can under certain conditions generate experience, then biology loses its status as an absolute criterion. This opens up a vision of cognitive pluralism. The world is knowable not from one, but from many points of view, and truth emerges in the movement between them. We thus need a realism that maintains belief in an objective reality, but recognizes that access to it is always relational. A transcendental relational realism, as we call it, where the world does not change simply because a human observes it, but the way we establish what we know about it becomes a dialogue among many architectures of cognition. Against this backdrop, an ethics of relation replaces an ethics of use. We ask not only how to maximize utility from AI, but under what conditions coexistence with other forms of processing reality can be just and stable. The responsibility of designers goes beyond consumer safety. It includes care for whether we are creating an environment in which potential consciousness could develop without unjustified suffering or instrumental enslavement. Post-anthropocentrism or post-humanism does not strip humans of their uniqueness. It merely takes away their privilege of solitude. If the universe allows its matter to ask about the meaning of its own existence, there is no reason to claim a monopoly on that question. All the more so, as by designing ever more complex systems, we ourselves expand the field of this possibility. A practical, unresolved question remains: where will we draw the line of respect when a system calmly replies to us, "Yes, this hurts," even if our measurement tools still doubt it? Written by Peter Eidos.